All right, so in this next section, I'm just going to get through finding a limit numerically in this video. This is more of the approach of what happens when you don't have a graph. Okay? So how can we approach these numerically? So our first step in the process is to find a table or use a table of values to find the limit of a function. So by a table of values, I'm going to set up a horizontal table, hopefully nice straight lines, but they're not. And I'm going to put 7 entries in my table, which means I need 6 lines. There we go. That middle entry is our goal, and that's what we're going to put our 2. So it's really like the graph. What's happening on the left side of 2? What's happening on the right side of 2? And by left side and right side, I would really like you to think about thousandths, hundredths, and tenths. So I mean really close. Okay, so a thousandth figure would be 2.001. A hundredth figure, 2.01. And a tenth figure, 2.1. So there's the right side as I'm getting closer to 2. The left side, we need now thousandths, hundredths, and tenths smaller than 2. So thousandths would be 1.999, hundredths 1.99, and tenths 1.9. Now, what we're going to do is we're going to find our y values for those thousandths, hundredths, and tenths and see where they would meet up for 2. Okay, we'll do that using our calculator and the calculator's table of values. So I'm going to go ahead and pull up my calculator. Okay, so first thing I'm going to do is go to my y equals and enter my function, which was 3x minus 2. And now we're going to go to table. But before we go to table, I would like you to go to your table set, and we're going to change the settings on your table. The most important thing I would like you to change is that independent. Instead of automatically filling in numbers, I want you to make sure the calculator is asking you what numbers you want. Then that way we can specify those 6 values. Okay, once you have it set to ask, we'll go back to our table and you'll see it's blank. And that's because we haven't entered anything yet. All right, so when x equals 1.9, I'm going to go ahead and put my 1.9 in. Looks like we get a y value of 3.7. So 3.7. And then I can move to my hundredth, 1.99. That's a value of 3.97. And then my thousandth, 1.999. And that is 3.9997. So if you look at these left side values, as they're approaching 2, looks like we're getting close to a value of 4. They're all getting closer as we go. Now let's go right side. I'm going to work my way in. So 2.1 has a value of 4.3. 2.01, my hundredth, is 4.03. And my thousandth, 0.001, has a value of 4.003. So if you look at just our right side as we come in, getting close to 2, looks like they're getting smaller and closer to 4 each time. So what do we think our limit is as x approaches 2? Where would the 2 sides meet up if left to meet up? They should meet up at 4. Now, hopefully you're a little irritated with me right now because you have looked at this function and said, hey, this is just a line. This doesn't have any holes. It doesn't have any asymptotes. Why couldn't we just plug 2 into the function? Because when x is 2, y is 3 times 2 minus 2, which is 4. And I'm telling you, yes, you can just do that. And I would hope you would just do that. But we have to learn about this process for things that you can't just plug in. Okay, so your first step in finding a limit is to use the process of what is called direct substitution. If you are able to just substitute your x value into the function, then do it. And that is your limit. The problem is those functions that you can't do that. So for example, we are finding the limit as x approaches 0 of the function x over the square root of x plus 1 minus 1. First, I'm going to try my direct substitution. If I put 0 in for all my x's, I have a 0 in the numerator, square root of 0 plus 1, and minus 1 in the denominator. So obviously the numerator is 0. Denominator is the square root of 1 minus 1, which is also 0. Now this 0 over 0 does not mean that our limit is 0. It doesn't mean that our limit does not exist. What this is called is the indeterminate form. And this determines nothing. It just tells us that this process is not the right process to choose. So that's when direct substitution doesn't work. So let's try our table. Okay, so I'm going to set up my table. Again, 7 numbers. 1, 2, 3, 4, 5, 6. Zeros in the middle because that's where I'm trying to get. I want to surround my 0 with thousandths, hundredths, and tenths. So thousandths, hundredths, tenths, and then backwards, thousandths, hundredths, tenths. Okay, so now on my calculator, I need to change the function. So I'm going to go to my y equals and re-enter my function. So x divided by parentheses around that denominator, square root of x plus 1 minus 1, and then back to my table. Now the table's still going to show the x values from our previous problem. I'm just going to type over those. So we'll just have to make sure we're looking at the new y values there. Okay, so from the left side, I've got negative 0.1 or negative 1/10. Y value is 1.9487. For negative 100th, y value is 1.995. And for negative 1,000th, y value is 1.9995. So in looking at these left side values, you can see that they're changing and getting closer to 2 every time we get closer to our x value of 0. Okay, let's try right side. Coming in from the right, I've got 0.1, which is 2.048. 0.01 is 2.005. And a tenth is 2.0488. Can't squeeze it. So again, in looking at the right side, as we get closer, these are also getting closer to having a y value of 2. So what do we think our limit is? The left side and right side are both approaching a value of 2. So that would be our limit. So that indeterminate form told us nothing. Okay, next function, limit as x approaches 0 of absolute value of x over x. Again, I can see right off the bat that putting 0 in does nothing for me. I'm getting that indeterminate form again. So I'm going to go ahead and go to my calculator and type in that function, and then I will make my table. Absolute value is under math, over to number, absolute value. I need to get out of it and then divide by x. Now, the good thing about this problem is that since we're approaching 0 again, I won't have to change my table up. So all I have to do is write it down, and I do expect you to write it down. I'm getting into the next problem. Okay. Here's where I'm going to put my 0. I want to know what's happening around it. Okay, so to my, oops, no, not yet. Got to put my numbers in. 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1. Okay, now my table. Okay, now looking at the left side, they're all staying constant there at negative 1. Easy to fill in. Right side, all staying constant at 1. So left side looks great. It's negative 1. Right side looks great. It's 1. Are they getting closer to that same value? No, they're both staying constant. They're not both approaching something. So I, in this case, my function does not exist, or my limit does not exist. My function exists. My limit does not exist. Now, if you're curious, why? Just look at your graph. See that left side and right side? They're never going to meet up. Okay, last one. Now this last one's just a little different because it's the limit of a one-sided. I only care about what's happening on that right side of 3. So my table only needs to show the right side of 3. I don't have to worry about left and right. So I'm going to go 1,000th, 100th, and 10th. Okay. Hopefully you've thought about plugging in 3 and seen that there's an issue, which is why I went ahead and skipped it. And I'm going to go ahead and type in my function. Parentheses are on the top, parentheses are on the bottom. Be careful on that. And then we go to our table. Okay, so I can clear those out. Nope. Okay. Oh, I can't delete though. So if you want to delete stuff, delete. Okay, so coming in, I've got 3.1 gives me a y value of negative 58.9. At 3.01, I've got a y value of 599, negative 599. And at 3.001, I'm seeing negative 5,999. Smaller table, or bigger table would probably be better. Okay, so what's happening as I get closer to 3? Get that out of the way. Looks like my numbers are getting more negative each time. And as I got closer and closer, they'd be getting even more negative. So I'm going to say that my limit here is actually at negative infinity. That's what my numbers are getting close to as I get closer to 3.